Good morning and good evening. So we are in session number 12 in today's class, and what I have for you today to cover the chapters called Comprehensions and also external files. So the reason why we can cover two topics or two chapters today is these two chapters are in short. There are very few topics to cover in each of these. So I have bundled together in one session so that we can cover both the chapters together. Okay, and as always, let's do a quick recap of what happened on what we have learned in session number 11. So session number 11 was completely on classes. We have covered the complete chapter. So first we defined what is a class, when to use a class, and what is the purpose of having a self clause inside the class. And then, as simple as defined, the class, the purpose of class is to group functions into one object, and you will have the flexibility of running those functions at any time that you wanted. So we also have a class which is pre-default available into your system, like date time. We have gone through it, right? Time delta, all of this. A class within a class is also possible. Modules, classes inside the modules are also possible. But what is a module, what is a package, what is library, and what is class? These are four different things that you might be thinking at this point of time. Just for the ease of understanding, all of these are one and the same for time being. Okay, but I'm sure we are going to hit the chapter called modules very soon, and when we get into that chapter we will understand what are the differences between these four things. But even after that, if you remember that all of these are one and the same, there is no problem, because all of them are exactly works very similar to each other. Okay, but if you call it differently, no problem at all. That is widely accepted in this world. Cool. So we did the classes. We have seen how to pass inputs to the classes, how to how to create a class without inputs, and we have also seen inheritances of the classes. And when there is a need of passing inputs for the inherited class, how do you make it possible using super as a function? We have seen all of this in the last session. Okay, so on that note, I would like to start today's session on comprehensions and external files. Okay, so let me do that right on the screen for you. And the topics that I have got for today are these. So comprehensions are very short thing for us to learn, but yet very, very powerful and important. Okay, then we are going to also cover the topics called external files. Okay, and again, very important topic, because in a real world you might get data in the form of a flat file or a normal file on your system, or you might get it through the databases, or you might get it through the web, or you might get it through a API call, or you might get it through a big data source, right? So all of this is possible. So this is one of the ways that you should learn how to deal with external files on the system, okay, from your Python. So let's quickly begin up with the comprehensions, with the definition first. To explain what is a list comprehension, I will have to take one example. Consider the same thing here. I have a variable called Oracle_string, and this variable has got this input, right? This is a value of this variable. As I'll be time, let me restart my kernel. All right. So this is the string, and this has got this value. Okay, from whatever experience you have got and whatever learnings you had so far in the Python programming, in case if I want you to extract each and every alphabet in this string into a list, elements of list, how do you program it? You basically create one single empty list called extract_text. This is an empty list. Then you start writing your code for loop. So I say for each of the alphabet, this can be anything, right? It's a variable name. Inside this string, do this extract.text.append, then each alphabet. Okay, so if when I execute these two together and then I print, right, my for loop is done, I print extract text. You see, each and every element, each and every character in this string has been extracted and it has been appended in the form of a list. This is a very, very regular way of, you can call it a conventional way or a traditional way of writing a program. Okay, Now, along with this, we can also use map and list that we have learned, right? What was that map and list? We have to make use of lambda function here, or even without lambda also. If I have to, okay, let's use lambda function for the ease of understanding. I would directly say extract underscore text2 is equals to map. What is that I have to do? Map this one, the function. Where is that string? So I'll use the same string. Okay, and what is that I have to do? For x in this, okay, for x in y, okay. Oh, I have to write lambda, right, inside map. I can't write like this in a for loop. Lambda x and x in this one, okay. So this is a map. Okay, is there any syntax for me? Okay, I think this comma. Okay, I'm missing something, so I can say this is okay, because this I'm not converting into a list. I should say list of this. Lambda, typo, yeah, typo. Cool. So this is a syntax. What did I say? Map lambda x comma x, x colon x. X is nothing but which is part of article underscore string, right? I convert that in the list. This we have seen when we have learned lambda, right? So as soon as I say this, everything is converted in the form of a list. This is another way of writing for the same purpose. Instead of using a for loop, you can use lambda. And lambda is executed with the help of map, and you can convert that output in the form of a list. And that output which is in the form of a list, I'm passing into another variable called extract text2. Now when I say extract text2, it's the same thing, right? So I have achieved my requirement. Okay. Now, what is list comprehension and where does it actually fit in? Instead of you writing some lambda function and then writing a map and then converting that map into a list and then saving into a file, you can directly write a list comprehension like this. If you say in a square braces, whatever you are going to write, that is a list comprehension. Okay. If after the is equals to or the first character of a command and the end character of a command is the square braces, you have started writing list comprehension. Remember this point. Okay. So just say x for x in article underscore string. That's it. So you have written a list comprehension. What is it? For the same purpose of writing it traditionally like this, instead what did you say? For x in article underscore string, you have to add x in your list. And you keep doing it until all the characters are exhausted into this, in this string. So if I do this, now if I say print extract 3, it is no different. It is no different from the earlier outcomes, see? But for the same requirement, we have multiple ways of writing a code. One, a traditional or a conventional way of writing a for loop. Two, I can use on the fly a lambda function. And if I have to use lambda, I have to use a map and I have to use a list. This is what is needed. Three is list comprehension way. Okay, even in the list comprehension way, you have to have a for loop. That is one thing that you have to make a note. But you need not write append, you need not write add, you need not basically create an element first and then keep adding new elements into the empty list. Nothing. Exactly the outcome of this command, I'm selecting only this piece and executing, exactly it is the outcome is a list. That is why it is called a list comprehension. Okay. So now I'll also take this opportunity to also make list comprehensions much more workable in the form of a nested for loop also. Okay, in one of the last sessions what we said is, if I have to create a list of even numbers between 0 and 19, what is the program that I have written for a nested for loop? For loop, and there is an if clause inside that, right? So let me do that. Article underscore even numbers. Okay, I'm creating an empty list first. Now what did I do? For x in range of 20, that means 0 to 19. If x percentile 2, which is nothing but reminder when you divide with 2, is double is equals to 0, only then you basically add, right, r__ even plus is equals to x. Or another way to append the same list is r__ even dot append of x. Either line number 22 or line number 23 is one and the same. It is the way that you wanted to append something into the list. I can use line number 22. I'm removing line number 23. Both are one and the same. Now after I execute this, what will be the outcome? Let's see. Now let me print r__ even. You see all the numbers between 0 and 20, that is 19 actually, because range of 20 will generate the maximum value as only 19. We have got all the even numbers here. Okay, so 2 is an even number, etc., etc. Now, how do I create this? How do I do this with the help of a list comprehensions? That's what we have to learn today, right? r__ even 2 is equals to, start a square braces first. Okay, now start typing this. For x, okay, y, okay, x, for x in range of 20, and then if x percentile 2 is equals to 0. Okay, I'm sorry, you don't need to use this syntax. The complete 3 lines code where you have to be worrying about the indentation of for loop, and inside the if loop there should be double indentation, and there should be colons, there should be append clause. All of this is not needed in list comprehension. Now if I execute this and then say print r__ even 2, it is one and the same as above, right? So the list comprehensions is a simplistic way of writing a loops on the elements of a list. Very importantly, why is it called a list comprehension is the outcome of a list comprehension is a list. Okay, so it is not basis on the input that you are giving inside a program of your one-line code. No, the outcome of that is a list in the form of a list. That is the reason it is called list comprehension. Okay. All right. Now I can make it much more complex also. Let's do that as well, right? I have some example here. For example, I wanted to get even numbers, but also if it is divisible by 5, right? I can also do that, right? I'm directly running this. So between 0 and 100, that is nothing but 99 actually. First, it will extract all the even numbers. And inside these even numbers, it will also check if it is divisible by 5. Only those numbers will be part of this output, right? I can write as complex as possible, but it is very simple now in the form of coding. See here, you get 0, 10, 20, 30, etc., etc. That's it. Okay. And between 0 and 10, if you only wanted to tell which number is odd and which number is even, you can also do this. See, if I percentile 2 is equals to 0, we call it even. If it is not, we call it odd. For I in range 10, but from 0 to 10. Okay, let's do this. So you print this. What happened? The first one is even, second one is odd. Third one is even, fourth one is odd. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, cool. And this is what you should basically remember of the list comprehensions. So the output of a list comprehension is the list. That is the reason it is given. The syntax is you basically write in a very simple braces, because that is the syntax of creating a list. And inside this list, you can directly start writing your conditions in a very, very simple for loop. So you have to take this as a reference and you start practicing the syntaxes. Okay. So let's move into dictionary comprehension. The only difference between dictionary and list data structure, what is the difference? We have indexes in the list, but we have keys in the dictionaries, right? So the only play for you is creating a dictionary and the resultant is a dictionary, but you are playing with key and value both, not just value. Here we have been only playing with the values of a list, right? But if you play with both key and value of a dictionary object and create an outcome as a dictionary, that is called dictionary comprehension. Okay, so to make it little easy, I'm creating one dict which is key is A, value is 1, key is B, value is 2, B is C is the key, value is 3. Similarly, D is the key and value is 4. Now when I create this dict, I would just print it for you on the screen, dict 1. So this is the dictionary that I have just created. These are the keys and these are the values. Now one of the possibilities when you create a dictionary is you can extract keys separately and values separately. So this is a syntax. If you want to only extract keys from the dictionary, you can get the keys like this in the form of a list. See here, all the keys which are available inside the dictionary. You can also extract all the values inside the dictionary also. Okay, and there is another default function for each and every dict called items. When you say items, each and every element of the dict is in the form of a tuple in the dictionary. If you take this up and only get onto the screen, and we will divide the outcome and understand what is outcome items is giving you. Basically this is an list, right? Just like keys and values, it is also generating a list. But when I said items, it is including both key and value in the list. And each key and value is grouped in the form of a set. Okay, I'm sorry, it is not a set, it is tuple. Okay, the syntax of set is curl braces, but here it is tuple. Okay, tuple of only 2 elements. This is how it is grouping. So these are the 3 important functions which are available for every dictionary object in the memory. Now why am I telling this? Because if you understand this, then you can play with dictionary comprehensions. If you want to change or do some changes to the keys on the fly, if you wanted to make changes to each and every value of a dict on the fly, you should know how to extract only keys, you should know how to extract only values, or you should also know how to extract both keys and values. Okay, now let's write a dict comprehension like you have here. So what I just wanted to extract is, if I have to extract this in the form of a dict, how will I do it? Okay, so the same thing I basically type just for your sake of understanding. I'm creating a variable. Now just like list comprehension starts with square braces, dictionary comprehension starts with curly or flower braces. Okay, I'm saying for each key and value is what you have to basically put it in the form of a dict. For key comma value, that is an outcome in article underscore dict 1 comma dot items. Now it should be very clear for you, right? What am I saying? For each and every element inside these items, that is nothing but this is the first element, right? This is the first element, this is the second element, this is the third element, and this is the fourth element. For each element inside this items command, first one is called key and the second one is called value. First one is called key, second one is called value. And you have to pass that key and value in this syntax and then call it another variable. Are you seeing any difference of doing this? No, right? Now if I say print and then article underscore dict underscore variable, is it any difference from basically article dict 1? No difference. That is what I wanted to first explain you. How can I extract key from a dictionary? How can I extract a value from the dictionary using items? Okay, now let's do the transformation. What I wanted to do is, for each and every value inside my dictionary, I wanted to multiply it with 100. Okay, so how do you do in a real world, in a normal world or a traditional way that you have learned? You have to first extract keys for each of this and you go identify the key value. So let's do that. Okay, for key k in article underscore dict1 dot keys. Okay, this is your for loop. You basically now do article underscore dict1. Let me create a dict2. Okay, underscore dict2 of that key value k. You multiply with for you multiply is equals to article underscore dict1 of key. This is the value. You multiply with 100. Okay, so now because I have to initiate this article dict2 is equals to, I basically create this file first. Okay, I created empty dictionary. Now for each key, what is the outcome of this? Key values of this dictionary, right? A. So what I'm saying is, inside this dictionary create the first key as A, but from this dictionary get the value of A and multiply with 100, call that as value of article dict2 for the same key. Okay, now when I execute this and then at the end I say print of article dict2, see here every element has been multiplied with 100. This is again a traditional way of executing some program on each and every value of a dictionary. Now how do I do it using dict comprehensions? Simple, right? Article underscore dict3 is equals to start the flower braces, and inside this flower braces, what is that you should do? Just say key and value into 100, where for what is k comma v in article underscore dict1 dot items. For each of these items, the first element is key, but the second element is a value. I'm calling it now k and v in very short. But when you basically extract this, put k as it is, but you multiply v with 100 and then save into dict3. Cool. Now let's say print article dict3. There you go. This is dictionary comprehensions. The advantage of dictionary comprehensions is you can also change keys as well. For example, I wanted to say AA. Okay, so the key name I have to change it as AA, BB, CC, DD. Okay, so how do I do it using dict comprehension? Instead of me having an operator here, I basically say an operator here to k, multiply it with 2. That means the alphabets will be repeated twice. Now I would say 4. I'm not changing the values, I'm only changing the keys. You can play with dictionary like this. Okay, so now you see AA, BB, CC, DD. So you can also have some operations over your keys also using dictionaries. Alright, so this is all about dictionary comprehensions and list comprehensions. These comprehensions are very, very important in today's world of programming, because it was not there when Python started, or not there at least before 5-6 years. People don't know until unless he's a very core Python programmer. But now it is very important to know these comprehensions. These are the easiest way of writing a 10-liner for loop in one single statement. Or inside a for, if you have multiple ifs, everything is in one single statement. And the output will generate a list automatically. Okay, that's why it is very powerful. Alright, so that is what you should be checking all other examples also in the below. So it's the same thing but different examples. Now let's go to a next chapter called external files. Let me give you an introduction of what is external files. In case if you have generated some variable inside Python, you wanted to save that output in an external file, so that tomorrow you will see the output of it. You are saving it somewhere. If this is your requirement, you need to know how to do it. Similarly, you got data from outside in the form of a file, and you wanted to get that data inside your Python kernel into one variable value. How to do it? Okay, so these are the two important things, along with the last and least important thing, how to remove a file existing in your location. Okay, these are the three important things that we are going to learn today or now. Okay, let's start with first of all, I wanted to, because I don't have any file available, so let me first of all create a file. To create a file, there are two ways to do it. I have to first create a variable, and there is a default function available inside your Python called open. And again, as always, open this link. This is python.org documentation help for open function. So I have opened it for you here. Okay, open is a function. And inside this, you can use the syntax. Give a file name and you have to specify what is a mode. And mode can be R, W, X, A, B, T plus. These are the available modes. And you can also have a combo. What does R means? Open a file which is already existing. Read a file. W means open the file for writing some data into the file. It is an output. X is exclusive creation. Failing if the file already exists. Okay, it will fail if the file already exists, else it will create the file for you. A is append. If the file already exists, if you wanted to append a new line into the file, you can use A. B is a binary mode. Most of us don't use it. It is purely for ASCII level programming guys. Okay. Then T is the text mode, which is by default available. That means you are creating a text file, not anything else. Plus is open for both updating and reading. We are going to see what are these combinations actually. Okay. So let's start first of all how to create a file. I basically say create a file called output file data.txt. I wanted to create this, but to create a file you can use either W or A. I'll start with W. That is write is a mode. Now I execute this, and this F can be anything. Okay. Now if I say f.write, okay, I have something called this is the first line of the file. Okay. Now I execute this one also. Do you see any file in this location yet? No, right? Because the lock exists in this file with a variable called f. Now as soon as I say f.close, you see what happens? There will be a file now available inside this. Okay, so let me refresh this one. If not, where is refresh? Reload from disk. See, output file data.txt has been created. Now I open it here. See what is the content inside that file. This is the first line of the file. Okay, I created it from here. Some data I have thrown into the file and I saved it on the external file. So you open it, you write into it, you close it. You can only write if you have opened the file in the write mode. And if this file name doesn't exist, it will create that file for you. This is the way you can create a file. Another way of creating a file is this. I'm copy pasting exactly the same thing, but another file name called data2.txt. Instead of W, I say A. Okay. This is using, this is the first line of the core file using append mode. Even in the append mode, if I do this and do this, I should see the second file in this location. I would just say reload from the disk. You see the second file here? Now this second file is exactly the value here. Now what is the difference between A mode and W mode? Okay. W mode will overwrite the file. Okay. For example, now I again use the same thing. What happens with this command? I would say the same file, but open it as a write mode, and I say second file, second line of the code. Okay. Now if I do this, okay, and I close it and open it again, see there is only one line. So write basically overwrites the file. If there was a file already existing with the same name, it will delete that file and it will create a new file. That is W, write mode. Now on the other hand, if I again copy paste the same thing here on the other file called file data2, but I say in the append mode, because the file already exists, it doesn't create. Instead, it will add a new line into this code called as second line. But I should also make sure I add a new line into the file manually. It doesn't add a new line. Okay. So now if I do this, what happens? I open this file again. You see, this is the second line of the code of the file. So now you understand that the append mode basically allows you to add new lines to the existing file. In the W mode, you basically are writing the file. It will overwrite whatever you want to create. Now, because these two files exist, and if you want to read it into a different variable, okay, so for example, I wanted to read whatever is there in this file into a different variable called, Oracle underscore data. I open this file in the form of a read only mode, and I read it into a variable called Oracle underscore read from file. Is a variable. I say f dot read everything into this variable and close the connection. Now if I print this variable Oracle underscore read from file, you see this is the second line that you see, because this file has got only one data in it, and I read it and I closed it. Okay, so what did you know? How to create a file using Python. One is using append mode and write mode. Append mode will add the data if the file already exists. The W mode will overwrite the file. That is the main thing. And until unless you close the file, the data is not refreshed. What does that mean? Again, I'll use the same one here as you have in the append mode, because you already have the second line. But I would say I'm adding third line into the same file, but I don't close it. For example, like this. And still the file is in the memory of Python. Now I double click this and see what is the data. The third line has not come yet because I did not close this file. Only after I close the file, okay, that data is made visible for me in the file. Okay, load file from the system changes. See, this has been added newly. All right. Now, how do I make this interactable? Even without closing the file, I should be seeing immediately the changes inside the file without closing it. That is when comes plus icon. So as you come back to your this one, plus open for updating and read write both together. So when I say this, I basically say append plus, and I say I am on the fourth line. Okay, I basically do this, but I don't close it. If I don't close it, I double click this. Okay, let me close this and I double click this. Basically, okay, I think it is not interactive. I'm sorry, this particular plus, I'll make sure what is the issue on this system. But what happens is, as per the documentation you see here, it opens up the file for both updating, and it is both reading and writing into the file. Okay, just like this, read plus, W plus, A plus, etc. Okay, so let me see what is the issue here. Why is it not behaving as expected? I'll update the same in the next session because I don't want to do a debugging stuff here. And but definitely when you close it, you will see that output, right? So let me open it again. You see the fourth line is here. Okay, so this is fine. This we already know. After the close we get it. But why is that the plus symbol is not making any effect on this system as told in the documentation? I'll do a bit of research and let you know in the next session. Okay, so now in case if you wanted to delete those files, you need again another there is the package or a library called OS. You have to import it, then say os dot remove the file from this location called output 2.txt or output.txt data.txt. I execute this. It now removes this file. Let's see. If I refresh this file should be gone, right? Refresh, reload from the data, gone. See, I can also say also remove my second file as well, right? It will remove that also. So removing a file is basically available inside my OS package. So let me refresh this. That file is also gone. Likewise, you can also remove a directory also. And the function that we have got is rmdir, and say what is the directory name. It will remove that directory as well if you have permissions. Okay. So coming back to the list that we have just gone through, we have understood what is list comprehensions. We have executed few small programs. We have understood dict comprehensions. We have understood how to create a file, write data into the file, how to read from the file, how to append the data to the existing file. All of these things we have completed in this session. Okay. So on this note, I can now take up any questions that you have at this point of time before we conclude the session. Okay, while somebody comes up with the questions, I'm just going through the topics that I had for you in the bottom so that I'm covered, not missing anything. Yeah, one more thing that you can be very, very sure of is if the file doesn't exist in the location, right? For example, I don't have this file at this point of time in my location. When I execute this, it basically throws an error saying no such file exists. In case if you wanted to handle it properly, first thing that you can do is os.path.exist. So only if this file exists, this is an if condition, only if this exists, you execute this command, else you don't execute. You can write it in better way, right? It doesn't execute because this is not there. You must be wondering what will be the outcome of this. It is true or false. So now if I only select this and execute, it is false. But I have this file called pfb_session12py, right? I will not use that actually. So let me use any other one. Session4_packages.py, because this exists. Now when this exists, see here outcome. I don't want to delete this, but the outcome is true. Okay. So when it is true, it goes into the if block and it will delete that file. So this way you can also better handle these exceptions on the operating system front. Okay. Any questions? No? Okay. So if you have no questions, we are done for the day. We will meet in the next session where we are going to cover the another important topic called data frames, and it is using a package called pandas. Some question? Yeah, Nikhil. Sorry, you're not so clear. Can you be? You mean path of the file? Yeah, exactly. That's a good point. So this, I'm making use of this file name directly. It is creating in the current directory, current working directory, right? But if these files exist somewhere else, the location is completely different, you have to pass in the complete path, like directory 1/directory 2/directory 3 until the location where actually the file exists, and file_name.txt. You have to give a full path. Okay. Thanks for that question. Yes, any further questions? Okay. Thank you then. See you in the next session. Bye bye.